Hello again. I'm back with some programming, and I had a thought sometime yesterday. Just let me check where I was. So we can load our voxel world, and we also construct the mesh correctly. And now it's just a question of connecting the neighboring rectangles up and down. That's really the only thing that's missing. So the thought that I had was I already know all the neighbors of the nodes. So why don't I just use those instead of doing all of this? So instead of doing this XZ thing, let's see, position. Yeah, this is the one that's not really needed. So I only really need all the contained nodes for all the rects. And then use the neighbors of those to find the neighbors of the rect. So we have this node rect, and I think we have all the positions. So what I need to do, we need the nodes, and we say X, Y, Z. This is node at position. And the Y is, of course, rect Y. And then we need the entity manager, and we say get component data. We need a voxel data component. No, not voxel data component. We need a get buffer of transition. What was it? Node transition buffer? Var neighbors. Why is this no bueno? Oh. Yeah, of course we need node at position, and that's read only. Node neighbors. we don't need this. And then we just say for each entity node neighbors. We need to get the containing rect. Which we get like this. Node. I cannot for each this. That's not enumerable. It is. Oh, yeah, of course. It's no transition buffer. Neighbor node. Neighbor node. Node. This is entity. Containing node rect. This gives us the rect entity, and we just have to say if this is different than the one we are currently looking at, then we add this as a neighbor. Because I was thinking we already know all the neighbors of the nodes, so we already have all that logic in place, how nodes become neighbors. So we shouldn't need to do the same thing for the rect. It just doesn't make any sense. And now this just works. This is why I didn't want to continue on Monday, because I felt like I'm about to do something stupid, and I was. This doesn't look correct, but that's because the center of this long rect is here. So that's still okay. I've been programming for so long that I can feel when my thoughts are stupid. Sometimes I just need to take a step back, think about what you're actually trying to achieve. Instead of just hammering down the first solution that comes to your mind. Okay, so this is perfect. So I don't need this down here. Anything else that is unused? No. Okay. So I'm gonna commit this. So this would be voxel graph creation, whatever. Okay. So the next step then is to do the actual path finding, which shouldn't be too different. If it's different at all, actually shouldn't be. I have two A star systems, and I had one for debugging purposes, but I'm not sure anymore which was which. I feel like this shouldn't be commented out. Buffer, path buffer. Oh, this is chunk index inquiry. Main path component. I want to say this is probably the correct one. But I'm gonna make a copy of this. So I'm just gonna call it voxel A star for now. Working title. Because we changed a few components. This is still the same, but this Nodeflow 3 is now obsolete. This is my Vox data comp. Graph. Yeah. Here we obviously also need a new one. Node float 3. Voxel graph. Voxel data component. Rikani ho and Kodashina Oni Nadareba Nachka Shiter Daro Savaleta Kakogoga Yudatemo Kumakasanai Wagamamario Sereba It's no Kyoga Chikao Meo Shiter. Why is this? Oh, make this internal. the distance between A and B used to be always 1 because they're always neighbors. But now we can go up and down. Let's keep it at 1. Voxel A star. A voxel graph. This is also voxel graph. Okay, and the rest is just A star. Yeah. System ID. I think this was also only for debugging. Find. Oh yeah, I used this field to say which one should do the pathfinding. Okay. Find path component. Set look for path system. So I think this was where we determined the path. So I'm also going to make a copy of this. Voxel look for path system. System. Okay, and this also uses voxel data component. Nodes. This needs all the graph information. Position buffer. Wait, what is this? Can you open this up for me, Jesus Christ? Position. Is this for the path? Find path component. Ugh. So this should be 3. Yeah, okay, so this only gets like a random goal. Okay, yeah, now I remember. This just sets the entity to walk towards a random space. we can't just say random bool anymore. So this uses the map size, but we actually need the voxel data component. Yeah, we just get all the possible voxels and then we just take a random one. Okay, so we already have all the nodes. How do I do this? State. Get entity. No, nodes queue. Get. Forgot how to use this. Where do I have queries? Tiles. Don't need this, I don't think. Notes. Temp. How do I resolve the query? Is it system API? Get entities. There are too many things to call. Query. I'm not even using these. Where am I using queries? Let's test. Nodes. To entity array. Oh, this needs a build entity manager. So actually now this can change. Or this will be able to change. We don't need this. So this is temp job. Let's put this here. I don't need the pawns, so scrap that. Nodes queue to entity array. Can I make this read only to entity array? Or can I? Get entity. Does this have a length or size? No. What are my options? To component array. That would be more helpful. Component data array. How's this different? The arrays of a component from all entities, the image array. I get the component data array. Anur, oh god, Anur 5. Oh wait, is that an S? Anur's egg. I cannot pronounce the name, but welcome. So this is also temp job. Can I ask a question? Sure, go ahead. Oh yeah, this has to be voxel data comp. So this is now my voxels. I want to learn JavaScript, but I don't know how to go about it. Do you have any previous programming experience, or are you just starting out from nothing? Voxels. I just know some basic C and C++. Okay, so I have some base knowledge. Thing with JavaScript is that it's very different from C-type languages. JavaScript is really different than any other language, really. The best way to learn JavaScript, I think there was online tools that you can use. Wait, let me Google it. JavaScript online. Because the thing with JavaScript is, it only works in a browser unless you're using Node.js. But if you want to learn JavaScript, then I assume you want to do some browser type stuff. The easiest way is using a page like I just linked, where you can write your JavaScript and execute it. If you want to run JavaScript locally, you would have to set up a local server. Otherwise, you're gonna get permission issues with your browser, because most browsers don't want to execute JavaScript from your hard drive for security reasons. So I would recommend using a site like this for starters, and then there's a very good website which is called what was it? Something www school. Ah yeah, W3 schools. And this has lots of stuff, including JavaScript. So there's great tutorials on there. Is it necessary to have knowledge about HTML and CSS before? No, not at all. Not at all. So HTML and CSS is completely separate. So they are completely separate languages. Usually JavaScript will be embedded in your HTML, but I wouldn't worry about that when you're just starting out. I would just focus on the pure JavaScript stuff. Yeah, in the W3 Schools website, they first have lots of languages, but they also have JavaScript. And they have extensive tutorials. And that's also a good site for generally looking up stuff. I think that's really all you need to get a foothold in JavaScript. You will probably also find tutorials on YouTube, although I wouldn't. Sometimes tutorials are a bit. I would always take it with a grain of salt. But yeah, when if you're just starting out, then the W3 Schools website, you can't go wrong with that, really. Yeah, I'd say that's all you really need. And if you want to go deeper into it, you could just find a video on YouTube on how to set up JavaScript on your computer. And maybe which IDE to use and whatnot, but I wouldn't worry about that just yet. Let's see, spawn data. We don't need spawn data. How should I decide which framework I should learn after I learn JavaScript? That entirely depends on what you want to do. I'm not super deep into JavaScript. I know a little bit. If, for instance, you want to make games, there is Pixie.js, which is very good. But outside of gaming, I don't really know what the most common frameworks are. I would just look for what's like the most widely used for whatever you're trying to do, and then go with that. Or you could also ask ChatGPT. Ask it like, I want to do X in JavaScript. What should I use? And it will usually give you a list of things. So I think I want to put a using in front of here. Maybe? I'm not sure. Don't need map this. Thank you very much for your advice. Yeah, no problem. I wish you the best of luck. JavaScript is a bit of a bitch, I'm not gonna lie. Okay, we need this guy here. So this is our... As soon as I start streaming, people start messaging me. Normally, no one cares about me. But as soon as I want to do some work, people are like, "Oh, Marco, what are you doing? Do you have time to talk?" No, I don't. Okay. So now we have this. I feel like this could take very long to execute. But there's no... Oh, wait, is this with all... Oh, this is read only by default. Okay. Okay, so now we just choose a random entry from this. Random... gold tile... voxels. This is just int. Random. Next int. Max is voxels length. For this we also use a random start tile, so because nothing is actually walking right now, we are only trying to get random paths. Voxels, global position, Oh, this needs the entity. Okay, and then this is just an entity array. Component to entity array. Okay. So this should be good enough. I think I did something similar to this in the beginning and it was pretty slow. but we will see. Okay, so we set up this find path component. And we need a pawn. We need we need this guy. And then nah, wait. Let's just say we don't want a pawn. We don't even need the position buffer. No, we do need the position buffer. That's right. We don't want the pawn. So for now, I just wanna really only find the path and then show it. So what we need is a find path component, and we need the position buffer, and we need the RNG. So we're just gonna create an entity that has all of this. Voxel stress test. So we just say private entity pathfinder. So, and when we're in here, we say entity manager, create entity, and we can put in component types. We're gonna say find path component. We need RNG, pathfinder, and we need entity manager add buffer, position buffer. And that should be all. Dynamic buffer, position buffer, find path component, and RNG. Okay. So this should then every time we clear out the path from the position buffer, set a new start and goal. And this should then be picked up by the voxel A star, which needs both of these. Yes. We set system ID to 3. Okay. That should do stuff. Maybe. Yeah, let's just start this. And we should get an entity. I should give it a name so I can find it. Stress test. How did I assign names? Name, set name. of Pathfinder. Pathfinder. We already had invalid operation exception. Entity key cannot be disposed. Which one? Entity query? Okay, maybe we don't use using here. Missing reference. Chunk mesh has been destroyed. Leak detected. Yeah, that's because of the dispose. Okay, lots of things. Job temp has allocations that are more than what was the proper way to do this? Do I call nodes queue dispose and voxels dispose here? It says to create queries on create, okay? Public void on create ref system state. Okay, so that was correct. But we don't build it here. Or do we? Oh, yeah, no, I think this is okay to do on create, also with the build. Because this will get the current data. The query is always the same. So we don't want to dispose this here. Instead, we do public void on destroy. I think that's correct. Nodes dispose. Okay. The previously scheduled job reads from the collection. Must call job handle complete. Where can deallocate? I see what you're saying, but if I call complete, okay, let's just Wait. State complete dependency. Job handle complete. State job handle. Or was it just job handle complete? Oh, wait. Job handle. System handle. The job. Job. This doesn't have a handle. Schedule. Schedule by ref. Schedule by ref. Perhaps. And this gives me a job handle? No. Wait. Was it dependency? Dependency. I put this in here. Oh yeah, and then I say state complete dependency. Okay, I think this what I have to do. It's still not completely clear to me what the best way is to do certain things. Select managed function failed to cast. First function pointer. This is a bug. Operates from voxels. Must call job handle complete on the job. Job. This doesn't have a. Or do I do job handle complete? No, that doesn't seem right. State dependency complete. Is it this? No. If I don't dispose at all, then it's also gonna complain. The system voxel look for path system writes find path component via voxel look for path system job, but that type was not assigned to the dependency property. What? How do I do stuff here? Here I only have the graph, which has the buffer lookup and the component lookup. But these are not disposable, so that's actually different. What other systems do I have? This just has one global hash map of tiles. They also didn't really change. Map spawn system. Yeah, no, that's also different. Move system also needs nothing. Oh wait, this is node entities. Ah, so this is similar. So what I do here is just get this array, has this in here, say schedule, say state dependency complete, and then this post. So that is probably what I should also do there. Yeah. Now it's complaining about the allocation. So new job schedule. Isn't this what I did previously? Hmm. Mm. Mm. This may be old. System seed must be non-zero. Oh. When I add the RNG, Pathfinder, no, entity manager, add component data, Pathfinder, new RNG value is 1. Okay, I think it's time to restart Unity. Bring me to life. Okay. So now we should have an entity which is called Pathfinder, which has a goal and a start, but nothing is happening in here. So where's my system? Voxel A star. Path buffer, find path component. Oh wait, that's position buffer? Path buffer. Position buffer. Path buffer. This uses the entity. So I do want to use the entity. At least I think I do. Kind of depends on... I think we are also using the entity to remember our current location. Let's look for path, one aspect, speed transform, yeah, current node. Okay. So we want the path buffer here. And we find all the entities. Thing is, if we use the entities whenever we need to find the next position. We have to ask the entity manager to get us the component. So would be better to have the position directly. Okay, let's go with this for now. Voxel data component. No, wait. Path buffer. Position buffer. Path buffer. Path buffer. This doesn't even need the buffer. We only need the... Oh no, it does need the buffer because we have to check if we're already going somewhere. Cannot be disposed. Yeah, okay, whatever. Where are all my entities? Okay. Pathfinder. Okay, so now this has start and goal. And we have a path. Okay. So now we want to draw that path with our gizmos. So let's put another bool and say draw path. If draw path, then we want to get our entity path buffer, entity manager, get path buffer, path finder, the path is this, and then for each... Why is this T? Node, 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 Entity manager, get component data, the data component of this. Actually, I need this to be for path length. Start at 1. And then we just draw Gizmo's line. Wait. Line list? No way. Read-only span? What is read-only span? Pointer? So yes, you're saying I could say list vector 3 Takanai no nara uta wo hanamuke toshi tori ni kaze ni tsuki ni nusunda ito wo zoto at or do I just say okay, make an array vector. I don't feel like this is simpler. Positions, new path, vector 3 path length, positions, voxel 1 global position. Yeah, this is int 3. Oh, wait, no, but I have to vector 3 int. And then I say gizmos draw line list. Oh, this works because the array is read-only span. I've never seen this type. Huh. Okay. So we put all of this in there. I could also say path select key entity manager get component data voxel data com global position to vector to air. P dot node to air. Oh yeah, this would be cast vector 3. I don't know, man. Is this... Is this easier to read than this? It's not shorter. And I think there's definitely more allocations in here than in this. Yeah, fuck it. Let's not do this. Okay. Okay, so we're gonna draw this. Narif? Oh, yes. And Pathfinder is not entity null. Okay. Still have one allocation. Draw path. Oh wait, is this... This might be somewhere down here. I don't see anything. Pathfinder node. This is... Zero 19. So somewhere here. No, this is... Right. Let's use a different color. Gizmos color red. Gizmos color white. Would be really nice if the gizmos had like a color stack where you could just push and pop the colors you're using. I think that would make things a lot simpler. Oops. Oh no. I hit my audio cable again. I should get a new one at some point, maybe in the future. Why are there faces? Oh yeah, that's between the chunks. No, that's correct. Plus vector up times 2. It's got to be somewhere. Ah. Here we are. Why is it so... Oh. Okay, so this... What the fuck? I thought you would, like... Is this now a dotted line, or is it... just doing pairwise? Okay, so... I thought this would be a useful method, maybe, but it's not. Okay. So that's our first path. So this is pretty boring, obviously, because we don't cross any borders. We have 22 positions. Ah, wait, I wasn't at the front of this. So this is 0, 0, 0. Okay. Okay. So next I want a button that lets me trigger another pathfinding. So we say private void new path, and we just say pathfinder. No, we say? Entity manager. How do I clear the buffer? Get buffer, path buffer, pathfinder, buffer clear. That should be it. Next. Okay, so this will be somewhere completely different. I mean, yeah, it's a valid path. The question is also, I mean, I don't think it's really a question, but you could ask whether or not characters would be able to only go like orthogonally or also go like at a random angle. Okay, now it gets a bit more interesting. So if we can only walk at 90-degree angles, then this is definitely the shortest path. Or one of the shortest paths. Obviously, you could also go like this. Or even like this. But the length of the path doesn't change. Okay, so this definitely works. Oh. Let me put more hills. Box the world test 2. We have a whole big area here. Let's push. We also have to make sure that the ramps work properly. Let's just build a wall here. Okay, so now we can make a few stairs. Um, okay. So now we should be able to see it walk across some hills. Stress test. Okay. Now this already looks much different. Uh, it's refusing to give me something on the hill. Oh, here we have something going up. Here we go, here and there. Bush, tush, tush, tush. And then up here. Yeah, that's definitely the shortest path. Here's another one. Yeah. Oh, there's the pyramid. I want to get something from here over there. Is this shorter than going there? Maybe it's the same. Okay, no, this is definitely not correct. This should go over here. And there are connections. Hmm. Yeah, no, here it should definitely use the ramp. Okay, I'm just gonna build something I can set the positions myself. Private void set path or set. Yeah, whatever. Vector 2. No, vector 3 in start. Vector 3 in goal. Button. We say new path and this is going to change it though. This is going to change it. Entity manager, get component, set component data, path find a new find component. Start goal and system is 3. Oh, this has to be an entity. How do I find the node at that position? Voxel graph creator. This has all the tiles with the position. Let's just make this public. Keep this in here. And then we say graph creator tiles. This item 1. So now this needs to be converted to int 3. Is there already a conversion? Of course not. 2, but I already made one. And same thing here. Go. And we want to say entity manager gets system. World, default world, get system. Voxel, look for path, system. System. Can I not pause? Oh. Or destroy or destroy system. Syshandle. Just don't make my job easy. Pause. If pause. Return. Blah. Get system. Dot. No. No, I just say false is true. So much garbage that I will have to clean up at some point. But for now, it only has to work. So now I could say like 40. Wait, no, X is Z is 40. And then I go to Noref, okay. Why do I get Noref? Okay, something in here is not, oh yeah. That would be it. Okay. 50. Okay, so it can't find path here because it doesn't recognize this for some reason. Okay. So let's see. A star. Why do you not find? We do have all the neighbors. So I don't see why that would not work. Estimate distance. Find path. Neighbors. No transition buffer. Current. Wait. The graph that I'm using. This is not the correct graph. I should be using the node rects. So it is this one. Okay, so I just used the wrong implementation. voxel A star. Partial? Internal. Yeah, okay, we use the rects. Do we need the tiles to find the path? Do we? Yeah. This is where we reconstruct. Find path. This uses position buffer. Okay. Bush to dush. So this is position buffer. We need to add position buffer here. Set path. New path. Position buffer clear. This should be a voxel data component. Graph rect node. Guess I need a copy of this. Right, I already have this. I think that's the same. Yeah. So this is actually this. Voxel data comp node. This is this. Origin rect. Oh, wait. Node rect. Wait. Wait, no, this doesn't even have to be different. Right. No, we need the node rect. Node rect. But the tiles. The tiles are the voxel data comp. So this is just that. And here we need the global position. Okay. 3. Okay, I think this was already the one where we don't only go at 90-degree angles. I'm almost sure. Argument exception. Oh yeah, we don't have a path buffer. That is correct. So now it's the position buffer again. And this is just position. Yeah, because the positions that we walk through are not equivalent to the voxels anymore. Wait, no. This is just this dot position. And this. So we just have to T1 is new. Oh wait, this position also needs a y coordinate now. So this needs to be a float 3, but then let me just nah, let's just change this. Float 3, and then I just have to cast this. Yes. Then there will be errors in here. Path buffer, create. So this should all be float 3 now. Global position. X, Y. Wait, that's just start global position. No? Oh, this is int. Can I cast this? No. Okay, so start position is just start X, start Y, start Z. Global position. Goal. Start position. What now? Ah, yeah. Okay. Find path has to be this and that. Oh. This is first goal and then start. So these should be the other way around. Oh, no, wait. That's a different method. Find path. There's another fine path here. Doof, doof, doof. Tile. Oh. Estimate distance. All of this is now float 3. Wait, my rects are still 2D. Oh fuck. Estimate distance. So this would be new target X and target X and target Z. This gives me a float 2, and then I have to turn that into a new float 3 with closest X origin Y and closest Y origin. Or, oh wait, origin rect Y. Target. Yeah, no, wait. I do the same thing here. X. Right, that should be origin. Get neighbor. Target rect entry point distance. Node 3 closest F3. Okay, so this will be broken, but I don't care. If we anything else? Yes. Main path. Hmm. The return. This should also be float 3. Ish float 3. This is float 3. So is all of this. reverse. Tile entry point. Full path. Get closest point in rect. Position. So this is again new last X and last plus Z. And then this would be closest X rect Y closest Z Y. Okay, this again has to go into a new closest F3. Okay. So the Y, yeah, no, the Y should be correct. I don't think this is completely correct. Maybe it is. Okay, I know we go at an angle. So I set this. This looks promising. This is, of course, not the shortest path from here to there. But we find this. This should also not work. Going from the side. This is also bullshit. I mean, okay, so it's somewhat what we're looking for, but not completely. Um, hmm, 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 hmm. That might just be a problem with the path construction. And we're going through the right nodes, but I don't really see why it would consider these neighbors. Should really go through here. Let's see. T 21. Oh, argument exception. Oh, yeah. So this must be 1. Hmm. 29, 28 is the stairs. 0, 27 is here. Mm. Okay, I'll be right back. Okay. So just looking at this. There is a shorter path. Mm. Mm. So what we're doing in step 1 is we only look at the rectangles. And that just minimizes the calculations that we have to do. So instead of looking at every too dry. Instead of looking at every single tile, we only look at the groupings. And that works. The rects we use are all the correct ones. We only have to find the best path in these rects. And if you can only walk at right angles, then that's pretty simple. Because you literally just look, okay, what is the closest point of my neighboring rect? So you just clamp this position to this rectangle, which gives you this point. Um, hmm. Hmm. So what do we do instead? Hmm. What do we do instead? So in this case, it is a straight line. So somehow we have to find out Hmm. 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 I have no ideas. Oh. So we could look at the straight line from start to finish. And then for all the sublines, we could try to minimize the angle. If we put this there. This is already straight line. Ah, okay, so this is still inside here, I guess. No. No, that's correct. Hmm. So we find the path. We start in this rectangle. We see, okay, this one already contains our target. So this is where we want to go. And then we just set the target location. And then to construct the path, we take this point, clamp it to this rectangle, which gives us this position right here. I mean, I guess it gives us this tile. And then we can just go on a straight line. Hmm. 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 It's actually harder than I thought. Hmm. Hmm. If I could I maybe clamp this to here and clamp this to here and then take the center? Would that be the shortest? This goes here. This is there. This is 1, 2, 3.5. So 1.75. That looks to be hmm. Okay, let's see. Previous rect. Came from here. hmm. Hmm. I don't have the positions. I only have the rects. I only have the rects. So I have my target point, my goal, and my start. Hmm. Hmm. There must be a way to do this. Finding the shortest path through some rectangles. Hmm. I have a start position. I clamp this here. I have a goal position which clamps here. And then we just take the center point. And that is the point I have to go through to have the shortest path. Maybe. But I don't know if this works with an arbitrary path. Like if my goal was back there somewhere. Hmm. Hmm. Let's do some drawing. So if, for instance, I have a path like this, I start here, then obviously the shortest path, we go here, then here, and then wherever we need to be in this. So just clamping these points to this rectangle is not enough. Hmm. I think I have to find the intersection point that is closest to this rectangle. Whatever the next one is. So if the next one is over here, then this is the closest. And if it's over here, then that still holds true. Only when it's like here, then there's several that it could be. And when it's over here, then this would be the closest. So to find the points I have to walk through, I have to look at 3 rectangles. And if I have a path like this, I mean, to take an extreme example, if the goal is over here, then it becomes obvious that I have to not look at the end point, but at the next one after my neighbor. So the question is, how do we find this point here? I think I can just use any point in here. So we take the center, for instance. We clamp it to this rectangle, and then we clamp that new point to the one in the middle. And that brings us here. And then we do the same for these three. So we do the same thing. We take this center point, we clamp it to this rectangle, and then we clamp it to the one in the middle, which is the same point. So we know to walk from here to there. Okay, so we have some point here. Let's go. So, and then we know to go here. And then we would go here next. But this is already wrong because this one would be shorter. So no, that's not correct. So this doesn't work. We're looking for a path like this. How do we know that we can go from here to there in a straight line? Do we? We clamp this to here, then this is just that point. We take this and clamp to here. Okay, I'm gonna ask ChatGPT. Maybe it knows an algorithm for this sort of problem. I have a set of connected rectangles. I am trying to find a line. I'm trying to find the shortest line through those rectangles. Let's call it a chain of connected rectangles. All rectangles are at most connected to two others. I know the rectangle to start from and the rectangle to end at. Do you know an algorithm that can find the shortest I am looking for a line that has the shortest length going through all rectangles. The line would be mostly straight, but can have angles where necessary. Do you know an algorithm that can do that? Okay. Yeah, we have a graph. I know that, but I'm not really looking at a graph here. Creating candidate path for each rectangle, identify the possible entry and exit points. Yeah, generate potential connections, calculate the length of each connection. I'm not looking to do Dijkstra on this. I don't think I have to use any fancy pathfinding on this. This seems like something that you can just calculate. I'm not really looking to find no, wait. I am almost sure that there should be a strict geometric approach to this problem. Since I am not really dealing with a full graph here, the rectangles themselves already represent the path I want to take. I just have to find the shortest connections between those rectangles. Yeah, the goal is to find the shortest line that passes through each rectangle in order while maintaining a mostly straight trajectory. This can be approached as an optimization problem using geometric principles without needing a full graph structure. Here's a more geometry-focused approach that leverages the layout of the rectangles. Represent the rectangles. Assume each rectangle has known coordinates for each corner or center with I indexing the rectangles. Yeah. Since you know the starting and ending rectangles, the order of traversal is fixed. Also correct. Identify the connection points. For each adjacent pair of rectangles, determine the possible points of entry and exit along their edges or vertices. Focus on finding entry and exit points that minimize the angle between successive segments. So perhaps what I have to do is we look at this shared line segment here. And then I have to find the point on that line segment that has the smallest angle to this rectangle. So we'll be looking at this and that. And this angle is more shallow. So that would be the point. And then I look at this line segment and this again. Now we have this as the shallowest angle. No, wait, this is the shallower. No, wait, what? No, this is the shallower angle. This is almost 90 degrees. This is more like 140 degrees. And then we have this line segment. We again look at these angles. And now no, this time this one is the shallower one, so that also doesn't quite do it. Use a geometric approach to minimize the total path length. For each pair of rectangles, Ri and Ri plus 1 determine the shortest line segment that connects them. Yeah, so this is always 1. So it would be this one here. This one was finding a pair of points, Pi, Ri, such that the distance between them is minimized and the angle between yeah. This can be visualized as forming a polyline through the rectangles. Each segment connects adjacent rectangles in the optimal way. Iterative angle adjustment. Start with initial connection points between adjacent rectangles by using midpoint of edges. Adjust these points iteratively to minimize the path length. Initialize connection points. Select initial entry and exit points. These can be midpoints of the edges facing adjacent rectangles. These can be midpoints of edges. So it wants to take the midpoint. Oh, wait. Maybe I understand. If I look at all of these connecting edges, then what I have to do is look at this. These 2 points, and then find the shortest line that goes through this. No. And then that would just... Wait. Maybe... So this is the closest point to here. And then this would give me... yellow is hard to see. That would give me like... So this is given... and that. And then I would have to look at this line segment, find the closest point to here. And then find the line that goes through here. And then we look at this edge and this point. And this has to be this again. I think now we're onto something. So if my target is in here, I look at this line segment, look at the target, find the shortest, the closest point on this line. That's my first point. And then we're looking at this. And we have to find the point on this line segment that is closest to this line segment. Which is this point. And then this turns into that. Oh, yeah. I'll be right back. Iterative soothing, adjust the points, such that the angles between segments are minimized. No, I think I found a solution. Okay, let's go through this one more time. So we have a start point here and our target is like here. So first we find all the line segments that connect my path. first we have to look from this point to this line segment. So we're always looking 2 ahead. So first we look at this, and then we have to figure out which point on this line segment is closest. There's a formula for that, I'm pretty sure. That would give us this point. So our first line segment would be this. Then we look at this point and this line segment. Yeah, the closest point on that line segment. Or it could really be any point on this line segment. It doesn't really matter, I don't think. And then we have to find the point on this line, which is closest to this line, which again would be this. So that would give us this as a next point. And if we look at this instead, then this is still the closest point. So we do this. Then we have this point and this point. So we have this line, and we again find the closest point on this line segment, which is this point, which gives us this, and then we are at our target. That looks to be like a reasonable algorithm. Let me just try one more thing. Oh, if we have something like this, or maybe let's do it like this. Then this would be my line segment, and my goal is maybe here. So we look at this. One of these points, it doesn't matter. Closest point is here. Then we look at this. Closest point is here. Then we look at this. Okay, so we have to look at the closest point. So first we have to find the shortest line from this point to this line segment. And then we have to find the shortest point on this line segment to this line segment. Okay, so we have to calculate two different things. And this would give us this. And then we have this point here. Do the same thing. I think that works. Okay, so now we have to figure out what is the formula for calculating the point that is closest to the right? What is the formula for calculating the point on a line segment which is closest to a given point? Vector projection. You have a line segment defined by 2 points. So when we're looking at this, we need to project what onto what? We have a line segment and we have a point P. You want to find the point C on the line segment AB that is closest to P, yes. Solution using vector projection. Define the vectors AP and AB. So we have AB and AP. Calculate the projection scalar T. The parameter T represents where the projection of AP onto AB falls on the line. AP dot AB, AB dot AB. Dot products and AB, the squared length of AB. If T is smaller than 0, the closest point C is A. It's bigger than 1, then the closest point is B. Okay. And if it's between that, then we just interpolate on the line. Okay, that seems pretty straightforward. So that is how we find the closest point on a line segment to another point. And then we have to find the closest point of this line segment to this line segment. How do I find the closest point on a line segment to another line segment? How do I find the closest point of a line segment to another line segment. To find the closest point between two line segments, let's call them A, B, and CD. You need to determine the pair of points, one on AB and one on CD, that are closest to each other. You need to determine the pair of points, one on AB and one on CD, that are closest to each other. The solution was checking for the closest points using vector geometry and can be done through the following approach. Line segment AB, CD, blah. We want to find the closest pair of points P on AB and Q on CD such that the distance between P and Q is minimized. So that wants to find a point on both line segments, but I only really need one. I only need the closest point on one of the line segments. Is there a simpler version for that? Yes, if you only need the closest point on one of the line segments to the other, the problem simplifies significantly. Okay, that's good. Here's a streamlined approach to find the point on one line segment that is closest to the other. Problem definition: line segment 1, AB, defined by endpoints A and B, line segment CD. We want to find a point point P on AB that is closest to the segment CD. Yes. To find the closest point on one line segment to another segment, you can use the following approach. Find closest points between segment AB and endpoints of segment CD. Project the endpoints of CD onto the segment AB. Okay, so we project these onto this line. This gives you two potential closest points AB to the segment CD. Okay, so this is one point, this is the other point. So we project to these 2 points. Calculate the distance from each endpoint of CD after projection onto AB. Right, what? Calculate the distance between CD and the closest point on AB. Calculate the distance from each endpoint of CD after projection onto AB. Oh, no. We project this onto this. So this projects onto here. I think. Like, would it be like this? Calculate the distance after projecting. Choose the point that gives the minimum distance. Steps to project a point onto a segment. Okay. Let's try to implement this. So, let's close all of this. How do I even start? Line segment test. Let's make this a mono behavior. And we just put all of this in start. So first we want to find the closest point of a line segment to a point. So we have a line segment. Is there like a line thing? No. Okay, so let's just make a line segment struct public int. No, let's use a vector here. Or no, let's use into A and B. Oops. B. The new line segment A is 0, 1 and B no wait, A is 0, 0 and B is 1, 0. Okay, so that's my line segment. Then we're gonna say we have a point. Oh wait, this should be float 2. Then we have a point float 2 P is let's just say 0, 0. So it's obvious what the result should be. Then we define two vectors. AB we already have, and then we need a vector AP. So float 2 AB is segment B minus A. and AP is P minus A and B minus A. AP and AB. And then we need the projection scalar. And maybe a project. There is a project, but this is for one vector onto another vector. Calculate the projection scalar. So we need AP dot AB. AP AB and divide that by AB the squared length math length times the length times the squared length of a float value. A B times the squared length of a float 2 vector. Yeah. We divide, and this is T. And then if T is smaller than 0, then our closest point is A. Float to C. Our closest point C is A. It's if T is bigger, then it's B. Else T is A plus TAB. I think that's just interpolation. Lerp. Segment AB T. Okay, and then we just debug log our C. Okay. Oh yeah, I know. We just make this a button. Calc closest segment to point. And we have to say float to A, float to B, and float to P, A, B. Okay, then we don't really need this line segment thing. We'll just say A, B, line segment test. Why are you taking so long to compile? Line segment test. Okay, so our line is 0, 0 to 1, 0. And P is 0, 0. So it should be 0, 0. And that is correct. And if it's 1, 0, then it's 1, 0. Okay. If it's anywhere in between, then that should be that. Okay, now when we say it's 10, it should be 1, 0. If it's minus 10, it should be 0, 0. Okay. So that seems good. If I put anything into y, should still be the same. Yeah. Okay. Segment 2 point. And then we need the segment to segment. Public void segment to segment. So we have A, B, C, and D. A, B, C, D. And we need nothing else. We want to find the point P on AB that is closest to the segment CD. Project the endpoint. Wait, yeah. For each endpoint of CD, project point onto line. That is what we already did here. Yeah. And that gives us T. And then we do that for C and D. And then we have to measure the distance from C to its projection and from D to its projection. Mm-hmm. Okay, so this is essentially just project point online. Yeah. So project P on AB. So we just have to get 2 points, load to CP is project ABC. Oh yeah, this needs to give us a return value, return C, and then we have DP, project D onto AB. And then we just have to get the smallest distance. Oh. Flow to C if oh, this is P. Float P if math F no math distance. Can we use distance squared? I think we can. Yeah. Distance between C and CP is greater than math distance between D and DP. Then P is DP, else P is CP. Debug log P. Stupid programming making me do math. Can't believe it. Okay, so this is 0, 0 and 1, 0. And let's say this is 0, 0 to 0, 1. So that should be 0, 0. Yes. And if this is 1, 1, wait. 1, 1, 2, 2, 2. So we have 0, 0, 2, 1, 0, and 1, 1, 2, 2, 2. So that should be 1, 0. Yeah. And if this is like 0.5, that's 0.50, yeah. Okay. Okay, I think that works. I'll be right back. Okay. So that's really all the math we need. We need to project points onto line segments and line segments onto line segments. So let's think this through one more time. Our path goes like there. Oh. So what we need to do to find this is we take this point and wait, we need this line segment. Oh yeah, wait. So we take this point and this point, draw a straight line. Then we project that line onto this line segment, which gives us the middle point, and that's that. If we have to go a bit further, then we would look from this point to this line segment, and we have to find the shortest line. And then that's this line. And we project it onto this line segment, which is here. No, that already doesn't sound right. How did I do this? We have this line right here. We take the shortest line from this to this segment, and the shortest from this segment to this segment, which gives us this. Then we go from here to there, get the shortest here, which gives us this. Then from here onto there. What happens when this is here? Then we still have this. Project this onto here. Then we have the shortest line here. No, it's not the shortest. fuck. It's not the shortest line from here to there. So, because that was put us here, and then we get this, which is not correct. We should get this straight line. Yeah. How do we get that line? Maybe first we have to project the start and the end point onto the respective line segment. Like this. Maybe just for the endpoint, because this doesn't change. And then this would be but what if the end is not there, but here? Or maybe then this would work again. Maybe it's even further down, like so. And then this would be here, and this would go here. And then we're at the same problem. How do we figure this out? It can't just be the closest point on this line segment. Or do I just look from the point where I am to the finish? And then I project this line onto this line, but that would give me this point. It's not quite. Or maybe I'd... If this does not work, So maybe I have to project onto everything until I find something that works, like that goes all the way through, or it's the next line segment after the current one. So I would project onto here. Then I'd have to I do this. And then it's easy to find out whether or not this line intersects with the line segments that I have drawn. So let's say this doesn't work and this is like down there. I have this point, this doesn't work. What do I do next? Do I get the closest point? No, I can't get the closest point because if we go one further, and that's actually there. And we're here. This doesn't work, but this works. So yeah, then it's the closest. Again, is there any case where this does not work? This is down here. If it's like this, then and I take the shortest. It's here. And we have this. And our target is down there. Then this doesn't work. Take the shortest here. This doesn't work. So we take the shortest here. And that does work. And then they go from here to maybe this works, maybe it doesn't. Here and then whatever. Okay, so we have to look. We always look at the endpoint. And then we have to check that this line intersects the next line segment. If it does intersect, right? If we look at it like this. And this intersects the next line segment. No, then this is not the shortest, because the shortest would be like this. This is longer. Okay, so we have to check that the line that we draw intersects all the line segments in between. Which is not difficult. And if it does, then that's good, then that's our shortest path. If it doesn't, then we go to the next line segment. And we need the shortest path between the two. The shortest line between our current point and the line segment we are looking at. And this also doesn't work, then we go one further back to the same thing. And this works, and this is our line. And if none of these work, and we arrive at this, at the next line segment, then we have to do the thing where we project, where we find the closest point on this line segment to this line, which is here, and then that is our next point. Yeah, I can find no other way to figure out where we should cross this line. Otherwise, other than really looking at all the line segments. Okay. So we have 3 things to do. Check this, check if it works or not. If it doesn't work, we go back to the same thing again. And if we arrive at this one, we have to find the closest point. So in this case, I would draw a straight line and check if it intersects both line segments. And then that's that. And if I'm here, then I draw this line and I see, okay, this doesn't intersect the line segments that I have to go through. Then I draw this line and see, okay, that works. So this is my straight line. And then that's another straight line. I think that works. Okay, so that means we're here in full path. This is what we have to change. So we have our rect. Okay, I think first we have to put all of this hash map into one list. So we say native list entity rect list is new allocate temp. Then we go from current rect. Actually, we say exactly this. While came from contains key current rect list at current rect rect came from current rect is this. Rect. Okay, so we put all of this came from rect in a list. And then we have the start position and the goal position. We start from the goal position. Shouldn't matter. And we need to get all the line segments. How do we get all the line segments? We need a struct. Private struct line segment. Public float to AB. And then we need a native list line segment intersections locator temp and then we say wait, we actually need the node rect, current rect. Do I get the rects? Rects containing node rect. Oh, nodes. So this is node rect nodes current rect nodes current rect. And then we say for rect list length, we start at 1. And then we need all the intersections. So we have node rect 1 and rect 2. And these have bottom left and extends. Top right. Okay, so how do we find the line segment? We do have all the corners. There's probably a smart formula here. Let's ask ChatGPT again. Do you know a formula that finds the shared line segment of two adjacent rectangles? Assume they are always assume that it always exists. To find the shared line segment between two adjacent rectangles, given that such a segment always exists, we need to determine which edge of each rectangle overlaps with an edge of the other. Here's a geometric approach to find this shared segment. This is also not straightforward. Okay. Rectangles R1 and R2 are adjacent and share a boundary line segment. Each rectangle is axis aligned, meaning its edges are parallel to the x-axis or y-axis. Yes. Yes. R1 is defined by its bottom left corner. R2 is defined by bottom left and top right corner, yeah? That's already what I have. I have bottom left corner and extends, but the top right is just bottom left plus extends. So finding the shared line segment. Since the rectangles are axis lines and adjacent, the shared segment will either be a vertical line segment where two vertical edges overlap or a horizontal line, yes. Check for vertical overlap. If the x coordinates of one edge of R1 match and an edge of R2, okay, I think I see where this is going. So actually, isn't it enough to just clamp? I clamp the bottom left point and the top right point onto this rectangle, and this gives me the line segment. Bottom left, top right, bottom left, top right, bottom left. Yeah. Yeah. Get closest point in rect. Yeah. Okay. No, that's easy. So I say rect 1. Get closest point in rect. Rect 2 bottom left. And yeah, this is, oops. This is A and top right, and this is B. Okay. And then we say rect list at oh wait, no. Intersections at new public line segment flow 2A, flow 2B. This A, blah blah blah. AB. Okay, these are our line segments. Now, We need this method. Put it in here, project A on B, project P on AB. And this is closest point from this from CD to AB. Closest point from AB, from CD to AB. On closest point on CD to AB. This is project P on AB. Node 2, return P. And then we need one public float to, no, public bool intersects float to a, no, we use the line segment A, line segment B. Here we can use the line segment AB, A, line A, line A, line B, line A, line A. And this is line segment line 1, line segment line 2, line 1A, line 1B, line 2A, line 1A, line 1B, line 2B, line 1. Oh, wait, line 1 like this. Private, and to check if they intersect. we do private float get interpolation value line segment line float to p that just gives us this t value. Line p. Let's make this a little bit shorter. And then we can say if get interpolation value a BA float t is this, if t is between 1 and 0, then it's true. Like this. Float t. We're essentially asking yeah, that is on the line. No, actually, that is not correct. No. How do I check if line AB intersects another line CD? Two line segments intersect if they straddle each other, or they are collinear and overlap. Orientation of 3 points P, Q, and R can be used to determine whether they form a left turn, right turn, or collinear. Oh boy. Conditions of line segment orientation. Okay, so we need to calculate some orientation values. That load orientation flow to A, float to P, Q, flow to R. And that is Qy minus Py times Rx minus Qx minus Qx minus Px. What the fuck? Times Ry minus Qy. Qy minus Py times Rx minus Qx minus Qx minus Px times Ry minus Qy. What? Okay. Orientation. Okay, so if it's 0, then it's collinear. Greater than 0 is clockwise. Smaller than 0 is counterclockwise. And now we need to calculate 4 orientations. Float 1 is orientation A, AB, and BA. O2 is A, B, and D. O3 is CD, E, D, and A. And O4 is C, D, and B. Points C and D lie on opposite sides of line A, B, and points what? The points C and D lie on opposite sides of line A, B, and points A and B lie on opposite sides of line CD when the line segments intersect. What? Okay, so if O1 is not equal to O2 and O3 is not equal to O4, if O1 not equal to O2 and 03 is not equal to 04, then they intersect. Points C and D line up on the sides of line AB. Okay, I'm just gonna trust you there. Check for special cases. If C lies on segment AB and is collinear with A and B, O1 equals 0, and C is on segment AB. The question is, do I need this? Or is this enough? Because we are, if we ever have a collinear thing, no, I think they can't be collinear. Because if they were, then we'd have a situation like this. So yeah, this can't happen anyway. I don't think. Can it? I don't think they can ever be collinear. Would be like this. No, I don't think they can be. So this should be enough. We don't have any special cases. Call this not intersections, call this overlapping segments. Okay. This is far more involved than I thought it would be. So now we say we have a current point which is our goal position. Goal post. Oh yeah, port 3. Oh yeah, I have to be careful with the y coordinate. So we say something like while current point is not start position. equals so then we say we make a line segment straight to goal or straight to start rather is new current point. Yeah, okay. So this is where the trouble begins. New current point X and current point Z to new start pos X and Z. Here we don't have to consider the y-axis. And then we say we need a current index for int e current index smaller than rect list. Yeah, smaller than rect list. No. Overlapping segments. And we have to check that it intersects all the segments in between. So make this into a method. Private bool intersects all native lists, line segment, lines, line segment, line. And we also need an index, start index. Start index, lines. If not line, and if not intersects this, return false, otherwise return true. Line intersects line I, yeah. If intersects all straight to start, overlapping segments, current index, then we found the path. So we say we say oh yeah, we need our result list, which is this result allocator temp path return path. So first we add the current at current point. If this intersects everything, then we would add the start, the start position. If this doesn't intersect everything in between, then we have to go one step back. Call this straight line. This also has to be a while. Is it a while? Maybe. While something. We want to do this. The start position. It's not always the start position. And then we would say we have something like a load to our current check pos, and this starts as this start position, current check position. Current check position. So this would be add this to list. Oh god, this is a mess. Start post. So like this. And if we got this, Then we would break out of here. I think this also needs to be a method. Oh boy. Private float to get straight intersection line or point. And we need float 3 start position. We need the current point. We need the current index. We need the overlapping segments. So here we would just return this. And then we say current check position is, oh god, int current line segment is 0. Current check position is line segment overlapping segments current line segment, and we need the closest point on that line segment project P on AB. Yeah. So we go from current point to that next line segment. Oh, we have to do this from the back. So overlapping segments count -1 length -1. And then we do minus minus. Actually, I think if this kind of thing doesn't work, if we reach the current we reach the next line segment, like in this case, then we just have to find the closest point of this line segment to this. Yeah. So we go until current line segment is, all right, what's the current index? That's also in reference to the line segment, I think. Do I even need the rects? I think I actually don't really need the rects. I only need the line segments. Actually, yeah. Actually, all these rectangles are completely irrelevant. All I need are these lines. I just have to find all the lines I have to cross. So while current line segment is greater than current index, I want to say. So we start from the back. We start from the last position. If that doesn't work, we go back to the line segment. If that doesn't work, we go back to the line segment before. And we start at 0. So we stop at 1. Yeah, we stop at 1. And if that still doesn't work, then we return. So this actually always returns something. Then we return at closest point on CD to AB, which is overlapping segments, current index, and overlapping, wait, like this. Closest point on CD to AB. And then we have to return the X. This Y. Wait, where do I find my Y? current position. Okay, I need the rects for my y. Okay, let's ignore the y for now. Let's just say current point y and then cy. And then we only need the closest. Okay, so actually, current point that was current index overlapping segments. This gives me next. Oh yeah, we just call this current point is here, path at current point, current index. And why is this not? Oh yeah, this needs x and current point z. Mm-hmm. Wire current index. Current index. Yeah, we just do this for all the line segments. So for I smaller than overlapping segments, length. And then at the end, we just add the start position. Wait. If this works, okay, actually, take this back for a second. At so for all the segments, first we add the goal position. So this is where we start. And then we do we start at the last line segment. Actually, let's take this out of the loop. let's just say we do this in the beginning and we always do this to the start position, and if this works, then that's just the start position, start pos Z, and then we can just break. So, and then we start looking at the line segments. And we need the closest point. Load to wait, we do this here. We go from the current position always. Load to current point to D is this. And okay. We need the closest closest point on this current line segment. What was the method for this? Project P on AB. Current lines, overlapping segments, current line segment to current point to D. Closest on line. So that is the line that we are checking. This has to intersect everything from I to the current line segment. Int end index. End index. So here, this has to be everything, overlapping segments, length. But here we just check until current line segment -1. because it will always intersect this last one. And if it does intersect all of that, then we need a new current point y z, no, this is y. And then we break out of this while loop. But we have to set I to current line segment and oh yeah, we need current point is this current point if intersects all current point becomes this and then we are at a new position. So let's say we go from here to there, and then our index our index is current line segment. I'm not sure if it's current line segment or current line segment -1. If this is bigger, yeah, no, this should be -1. Then we're done with this. And if this doesn't work, then we just say current line segment -1. And if we don't find anything in here, so we have to check found line. Say found line is true. We go through this entire loop without finding any of this. Then we do this. And when we reach the end, so this is this length -1. And we check this with the start position. Oh yeah, no, we can just say this is -1. Actually, no. Because if we go... No, if you go straight to the start position... Yeah, then we just break out. So we have to say if I overlapping segments length -1, then we just add the start position and we're out of here. Yeah. Oh. Line 2A, line 2B. Oh boy. I'll be right back. Okay, this is probably not gonna work. So now starts the debugging. Okay, so first we have an argument exception. Entity does not exist. Voxel A star. Checklist. Nodes. Rect came from I think this came from, doesn't have the rects, but it has the blocks. Came from tile. Yeah. So came from. Oh wait. Came from. Wait. Notes. Oh. Contract. No. Huh? This is the correct. Correct list. What? Entity does not exist. System string. Yeah. Okay. Let's disable burst. I think we need to recompile. The entity does not exist. Entities generally may be to determine automation. Okay, please enable journaling. Entities journaling. This here. Entity doesn't exist. Entity null was previously destroyed in world loading world. What? Contract. Hmm. Hmm. Came from. I did this exact same thing here. Notes. Okay, I feel like we are in an endless loop somewhere. Ah, yeah, of course. Because current rect. Rect. Current node nodes current yeah, we have to kill Unity once. Preference. Current pref current rect pref rect. Come on, Unity. We were just open. Why are we re-importing everything? Okay. Current rect. Huh? Can I convert from node rect to entity? This is entity. What are you talking about? Entity does not exist. What the fuck? Came from... The entity does not exist. Previously destroyed. Do I get the same shit here? No. This works just fine. Then why? Why current rect is not start rect? Okay, maybe we do this. While current rect is not start rect. And then we have to add start rect at the end. Rect list at start rect. Notes. Okay. It's not. It's not really correct. Oh, but this is definitely correct so far. Oh. This continues to be correct. I am surprised. So this should also be only 2 2 points in that path. Just a freaking straight line. Hierarchy. Pathfinder. Yeah. Oh. Okay, so if we go one further. Now I don't know where I was. 7. Straight line, yeah. Okay, so that's not right. Hmm. The intersection thing doesn't seem to work. Yeah. Okay. Oh, we also have. Oh, okay. Yeah, that doesn't matter. Okay. I'm gonna stop for today. I know where to continue next time. I thank you all for hanging out, and I'll see you next Monday, probably. Bye bye.